functions, all powers, functions with powers, x to some power, even a number times x to some power. Okay? When you get down to it, like that summarizes everything. We have rules, like the Costa-Multiple rule, and its power rule is one of the 7 difference rules. These are all rules. The actual function that you can take the derivative of is like one kind, x to some power. That's it, right? Or at least that's a lot of it. Then you have Costa-Multiple rules, so that as you bring down the power, you actually multiply by the coefficient. Like all this stuff, we really can take the derivative of broad spectrum of functions. So it all comes down to being able to do that power. Okay, what other functions do we know the derivative of? Is that trig functions, sine, cosine, tangent, secant, and to a lesser degree, cosecant. Sine, cosine, tangent, and secant, those are your main 4 that you're going to want to become so familiar with that you have memorized them, right? Okay, so we got polynomial functions, or when it comes down to it, just x to a power. A variable to a power, you can take the derivative of that. And trig functions. You can make it look complicated if you just have those 2 simple values. So we'll learn more in the future. It's not going to be today. It's not going to be exactly but we'll learn the derivatives of exponential functions and log functions, inverse trig functions, all this different stuff. Okay, right now, when you think about it, lead functions, when we actually come down and take a derivative, x to a power, or sine, cosine, tangent, cosecant, cosecant. plus G prime is cosine, times F, which is cosine. Well, what was that? That was just that G prime. Right? That's just the derivative of that thing. Okay? That's all done. And now we've done that. And now we need to use F, which is x plus 1. Cosine, sine, sine, is plus negative, well, let's say this, cosine squared minus sine squared times x plus 1. What's the distribute these together and cosine squared minus sine squared, that's not what we did. Cosine squared plus sine squared. That's not what that is. What do you need these two? Yeah, sine times sine. Switch the order because it's just addition.
Negative sine here.
This one? Yeah. Just negative sine times sine would be negative times positive. Negative sine. Right. Instead of writing negative plus something else, positive minus. Okay. So we just separated. So we can do the same thing with composition of functions. We can go function inside of function inside. Keep that down. We're just gonna have to unpack. But now we just don't have to unpack this function. Well, if we're gonna unpack these functions, we need to be able to recognize which function is inside the function. What's the inside function? And what's the outside function? Okay, so that's the first we're going to do. We're just going to do the homeworks, numbers, well, we'll do 1 and 2 together, and then have you do 3, 2, 6. So this is 2.4. They ask these next two is g of x, which is going to be the inside function. It's going to go inside f of u, right? Chose u just so that we have x. So we got to decide what function is on the inside of each function. It's like so now. What do you think? What's the inside? Sarah? Minus 4, you can see. We have to break it down into functions that we come on, yeah. Okay, and then what is the outside function? What does this go inside of? Right, u. So some function is u to the 4th. And then if we take this guy and we replace u with that, we get this composition of functions. Okay? When we talk about this, we talk about the inside and the outside function. It's got to work, first of all. Compose the two functions together, it's got to make that function. And then when we do that, we have to do it in such a way that the inside function we can take the derivative of, the outside function we can take the derivative. Can you take the derivative of this function? Yeah. Can you take the derivative of this? Yes. Yeah? Well, I guess it would depend. If what we're saying y is, y should be equal to, in the way that we've written it here, f of g of x. Okay. If you're saying, let's switch it up, let's make f, let's reverse them, then in that case, it's certainly important. I mean, it does make a difference which function goes inside the other function. Right?
Yeah, that's,
Yeah.
which
Which is inside of each test. G is typically inside and F is typically outside. So we'll assume we're doing F of G of X. We could do G of F of X, and then we would need to reverse these two.
yeah, the F on the outside.
Yeah, okay, yeah. So F's on the outside, G's on the inside. This is the outside. This is the inside. Okay, so we did that one. Let's do number 2, and then I'm going to have you do the rest yourself. 1 over the square root of x plus 1. Continuing these columns down. Square root of x plus 1.
Could it be like just X plus 1 for G of X?
Yes.
Could you do it like for G of X, let's have X plus 1 for F?
Yeah. Yeah, there are options. So you could say x plus 1 over the square root of u. Okay. Which is probably at this stage what we're supposed to do it this way. Because we can take the derivative of this, right? We can write this as u to the negative 1 half. That we can take the derivative of this. But you see this function is itself a composition. I can take the square root of x. I can take the derivative of the square root of x. But I don't have any idea how to take the derivative of the square root of x plus 1 inside x. Though once we know how to take the derivative of a composition of functions, it's called the chain. Use the chain. One time, and then when we came trying to take the derivative of this, we used it again. This way only makes us use it twice, or once. This is twice. So, either one of these is good. This will be fast. Alright, so 3 through 6, take a look at those, see if you can decompose them. Find out which is the inside and which is the outside. Okay. So number 3, excuse me. 3 is the square root of x squared minus 1. So we've got the, what's the inside function? Right, that's inside of what function? Square root of something, right? We just want to, whether we use u or x or m or, doesn't matter. It's the square root of something. Okay, here we have 3 times the tangent of pi x squared. Yeah? So what function is inside?
Pi x squared.
Pi x squared, and what function is it inside of? 3 tangent of u. And keep in mind, 3 is just a constant multiple, so we take the derivative of the tangent and multiply by 3. Right? Just a constant multiple, so no problem there. 5 equals cosecant cube x. This one's a little bit trickier. What function is inside?
Cosecant x.
Cosecant of x. What function is it inside of?
U cubed.
U cubed.
Oh.
Remember, when we say trig function cubed of x, it means take the value of the cosecant of x and cube it. So
Now you can see it's more. A lot of times what we get is really looks like one function is contained by another, either by a parentheses most often, or a square root, or maybe an absolute value, or something like that. Okay. And number 6. No, right there. Cosine of 3 halves x. Cosine of 3 halves x. Right, so what function is inside? 3 halves x. There's this assumed parentheses here. So 3 halves x. And what's on the outside? Cosine of something. Alright. So that's an important ability to have. If you're not able to pick these apart and say, here's the outside function, and here's the inside function, and identify them as distinct functions, you're going to have trouble, because that's just the beginning. Okay. Yep?
For 5 and 6, I got the wrong answer. For like, I thought that f of u was cosine of u divided by 2, and then g of x was 3x, but
Yeah.
Oh, yeah, the 3 halves x is inside the cosine function.
oh,
It's not, the cosine of like x over 2 is not the same as the cosine of x, the entire thing divided by 2.
so what about over 5?
What about it?
You got
Trying to figure it out, but wouldn't it be cosecant cube of x, or would it be different? Like,
Well, it's cosecant cubed of x to start with, which that's just all that means is this. Take the cosecant of x and then cube it. So now you can see physically cosecant of x is inside a parentheses, and the parentheses is being cubed. Okay, so let's see what life would be like if we never understood the chain rule that we're going to learn today. Okay, and take the derivative of these functions.
No.
Let's say f of x. So take the derivative of that one. This one.
Slow down.
This one.
So we're taking the derivative of each of these.
Yep, separately.
Stop.
Well, just those two. Do those two. See what you come up with. Taking the derivatives of those two functions. Not the chain rule? We don't even know what the chain rule is yet. How do we take the derivative of this function currently with our current skill set?
product?
We could do the product of two functions. X plus 1 times x plus 1, and we could use this, view this as the first function and the second function, f prime times g plus g prime times f, or we could just FOIL these, x squared plus 2x plus 1.
Foil.
I think it's a little bit.
Told us never to use foil.
Foil.
I'm glad you objected. That's very good.
So
Okay.
don't ever say it again. Yeah.
Okay. What about if I wrap up some leftovers?
Well, that's
the
ceramic.
ceramic.
Oh,
Yeah.
No!
Yeah.
Tupperware.
I'm not supposed to put foil on
Let's
it.
use an aluminum wrap.
Aluminum wrap.
No.
Yeah.
Okay. All right, 2x plus 2, that's the derivative. How about this one? How do we take the derivative of this one?
Same way.
Multiply it all out, yeah, that's the way it's going to be. So we got x squared plus 4x plus 4. That's 2 of those multiplied together, multiplied by another one, and then we get x to the third. Okay, this will give us an x squared, and this will give us an x squared. So 2x squared plus 4x squared is 6x squared. Then we get 4x and 8x, right? So 12x plus 4 times 2, that's 8. Then we take the derivative, and so f prime is 3x squared plus 12x plus 12. Cool. Alright. So what if I did this?
No.
No. Chain roll.
The chain roll starts to look really, really attractive. Okay, so let's write down the chain rule and we'll apply the chain rule to all of these. So easy. Okay? The hardest part about the chain rule is just keeping it all straight in your mind, which means you might want to write stuff down more than you will in the future because you'll be better at it. But if we have f of g of x, okay, get ready for this. The derivative of this is equal to f prime of g of x times g prime of x. So probably doesn't make a whole lot of sense quite yet. But all it is we take the derivative of the outside, treating the inside as if it were just some variable, okay? Which means we're not going to do anything to it. We're not going to take the derivative of this and then inside of that put the derivative of g, okay? That's not how this works, okay? You take the derivative of the outside as if what's inside is just a single variable, okay? And then we look at the inside once we're done doing this part and we multiply by the derivative of the inside. So how does that work? Well, what we have here is the inside function of x plus 1 and an outside function of 2. Okay? So just like we did in the previous exercises 1 through 6, here is u, right?
Yeah.
And here is, it's squared. U is squared. So how would you take the derivative of u squared? 2 times u. Just u, right? Not 2 and then something other than u. Don't change what u is. Okay, so we just bring down this this power into the coefficient here. Okay, so the first part is 2 times u. Okay, that's this part. That's just f prime. That's just the derivative of the outside. Okay. Then we multiply by the derivative of the inside. What's the derivative of the inside?
1.
The derivative of it is just 1. Just 1.
Wait, so you plug in g, that's for you?
Yeah.
You do agree.
So it'd just be
You don't
2
what?
plus
You don't put, like, you.
You don't put u because like in this kind of u would mean nothing, right?
Yeah.
U is the thing we use to represent what gets what gets replaced by this other function. Okay.
So after
Then it's
g
just
of
2x
x
plus
would
2.
be 2x plus 2.
Yeah, we just distribute the 2, we get 2x plus 2. Okay? Well, that already that was faster, right?
Yeah.
Radel.
It was already
That was
faster.
very nice.
Not debatable. That was faster. It was faster than multiplying these together and then taking the derivative.
Radel.
All right. Well, this next one won't be debatable. Here we have the inside function of x plus 2, outside function of something cubed.
So it's 3x
plus
plus 6.
3. What's that?
Wait.
What?
Whoa, hold on now, hold
Never
on,
mind,
hold
never
on,
mind,
hold
never
on,
mind.
hold on.
Not 3 times x
We
plus
treat this as if it were u, like if it was just a variable, right? We leave it alone, essentially. We don't do anything to it until it comes time to multiply by its derivative, to multiply by the derivative of the inside.
So it'd be 3 times x plus 2.
3 times x
Yeah.
plus 2 squared, just
Squared.
like if this were just x, right? We just leave it alone.
Oh.
3 times the thing being cubed, 3 times the thing being cubed, and then we subtract 1 from the power.
Times 1.
Times the derivative of the inside. 1.
See, why can't our work like this?
So it's just 3 times x plus 2 squared. We could leave it like that. If we were to multiply this together, we get x plus 4x plus 4, or x squared plus 4x plus 4, times 3, would give us 3x squared plus 12x plus 12.
So this is basically just the power rule, kind of?
If the power rule is necessary to take the derivative,
Well, I mean, you're just taking the power down and.
yeah.
Like,
We use the power rule on the outside function because I happen to choose a function that was a power function. But if I choose a trig function or a square root function or something like that, or well, not a square root, a trig function inside of another trig function, then we don't use the power rule. Yeah.
Could you use a chain function on the one that you got out of the chain function? Like just on the inside part, or no? There's two.
Well, see, you're trying to take the derivative of this, which would be the second derivative. right? So we could do that, and we would use the chain rule on it, but we don't need to. Because nobody asked us to do that. So here we come to this one, we didn't even try to multiply this one out
So
into
it
it.
would be 4 times
X plus 4 cubed.
cubed times,
Times 1.
I
real big.
Here, let's change it.
thanks folks.
Let's change it. We'll make the inside function so that it doesn't have a derivative of 1, because that's a little too easy. Let's just try x squared plus 4 to the
So it would be 4 times x squared plus 4 to the yeah,
the third.
times
2.
2x.
Times 2x.
And we can leave it there?
Absolutely.
Thank God.
Nice.
You can?
Sure.
Cool.
I mean, if we didn't leave it like that, then what we would do is multiply all this out, right? But we are using the chain rule to, yeah, we're trying to avoid that in the first place. We could have multiplied this all out and taken the derivative that way. But why don't we save ourselves some time and not do that? Because what we most of the time want to do is use the derivative to do things like find horizontal tangent lines, or find what the slope is 2, or whatever we want to do with it. Okay?
Keep it down back there.
All right. How about the sine of x squared? Now, without the chain rule, these ones are time consuming. Without the chain rule, this one is impossible. You can't multiply it out or something and be able to take the derivative of it. And they're not any like trig identity that we're used to using takes sine of x squared and turns it into something. There's sine squared of x, right? There's that, but sine of x squared is different. Okay? So what's the outside function? What's containing another function? The sine, okay? So we're going to take the derivative of the sine of u, or the sine of whatever is inside, right? The inside of this, when we take the derivative of the outside, the inside doesn't change. It's only after we take the derivative of the outside that we then multiply by the derivative of the inside. Okay. So f prime, what's the derivative of the sine?
Cosine.
Cosine of what?
U.
And what's u? U's x squared
And then times 2x.
times 2x. So we can write 2x cosine x squared. It's done. That was easy, super easy.
I want to.
Take the derivative of the
No.
composition of functions.
Okay.
Okay.
It's hard, yeah. That's gonna get harder.
Of course. Why would it stay easy forever?
Like,
It doesn't ever stay easy for a short time.
23. 23 is x squared
I've been writing these all down.
times x minus 2 to the 4th. Tell me something that you're noticing about this function.
it looks hard.
Huh?
The powers.
The powers? What do you mean by the powers?
Whoa.
Yeah.
There's already.
X is on the outside.
Hmm?
X is on the outside.
Okay, so there's an inside, there's an outside,
But then there's something
and there's
about
this x squared. What's the x squared doing to this function? It's what?
Constant multiple.
Who's what?
He introduced the product rule.
Product rule. This is not a constant, so it's not the constant multiple rule. We have a function times another function, and this function needs the chain rule to take the derivative.
No.
Wait, so would you
2x.
use the product rule?
Now,
of
just
the
hold on.
chain rule?
What's that?
So would you find the chain rule of x minus 2 to the 4th and then use the product rule with x squared?
Well, here's what it's going to be. Here's what it's going to be. Okay. And the big function, like all together, is two functions multiplied together. Okay. So we're going to need to take the product rule. Okay. So let's call this function u and this function v. Is that okay? Is that going to confuse anybody with this u is a different u? Okay. Let's
Yeah, it's a little weird.
let's do this.
I hate you and
As
me.
long as it's not t and times.
We'll just do v and w. We'll just move down the alphabet.
Let's do it.
V and w. Because u is the one that we use to represent x minus 2. Okay, so we'll not do that. All right. So the derivative of the product of v and w is just going to be v prime w plus w prime, let's say, times v. Okay, so let's say v prime, no problem, can take the derivative of v. W, no problem, I can rewrite something, I can copy and paste that. Plus w prime, so that's the second function, we're supposed to take the derivative of that, right? So we need to use the chain rule. So this part, when we take this derivative, we have to use the chain rule on that. So I'll just write chain rule right there.
No.
Right in the bathroom.
Yeah, as long as you're using the chain rule, take the derivative of that second function. And then times v, no problem. V is just x squared. Okay? So let's just go down the line. Like,
So.
I think this is kind of working out nicely. This is not something I've used before, but I think it is a nice way to keep track of all the steps.
I like that.
Yeah?
So are we not including the fourth power in it? Like, is it gonna be like v and w together are like u in a way?
So it'd be like
Like,
No.
4x. Or.
This right here, this is u, right? And as much as we're talking about
So
f of u,
Squared.
So u of four, f of,
Kinda write it down.
I don't know how to put this, but it's like there's another function dealing with w as a variable, and then it's like w to the fourth. Is that what's going on with the?
no, w is this whole thing. X minus 2 raised to the fourth, that's the function we're calling w.
Okay, I just wasn't sure because when you did the little bracket,
Yeah.
thing, I thought it was just x minus 2, and I was wondering if
That's fair.
we're just leaving out the fourth or not.
Nope,
So-
I should have made it wider. It's including that one.
Alright.
Good question. Okay, so v prime would be the derivative of v, which is x squared. That's 2x. That part's done. Okay. Times w, which is x minus 2 to the fourth. We just we cleared that up. Okay, that part's done. Plus, we go to take w prime, and hey, that's the thing we need to use the chain rule on. So it'd be
4 minus 2 to the third.
4 times x minus 2 to the third.
You're gonna get so dumb.
Times x minus 2 times the derivative of x minus 2.
Times what?
That one. Okay, so we did the chain rule, so that's done. And then we do times v, which is x squared.
And we can leave it like that. Why are there
Wait, we don't have to
derivatives?
go any further?
Why are there derivatives?
Yeah, like what were they
Find the slope
made
at
up
a
for?
point.
Like,
Slope
The slope at a point. Remember?
yeah.
That's
I
what
it looks so similar
Silly,
that
Connor.
it feels like
Sorry.
we're just
Yeah.
changing.
We could do that, simplify for 2x.
Right?
Simplify it.
Something.
Oh, like factor it out.
Thank you, oh my god, I'm.
So in the chain rule, is x squared not even?
The chain rule is only for taking the derivative of this function.
Okay. Right?
So this is a product of two functions.
Mhm.
Two.
Okay, I want everybody to be paying attention to
X
this.
minus 2.
Okay? This is a product of two functions, and so we need the product rule to take the derivative. And we know the product rule.
Yeah.
It's first derivative, the first function's derivative times the second funtion's derivative times the first function. When it comes time to take the derivative of the second function, this guy right here, we have to do the chain rule to take the derivative.
Okay.
Okay? So, and Sarah's saying we can factor out a 2 and an x. We could also factor out 3 factors of x minus 2 and x minus 2 cubed. X minus 2 cubed.
Oh, I see. It's
Okay? So we factored out a 2, factored out an x, factored out 3 of these, so we're just left with x minus 2. Plus, factored out a 2, so we got 2 left. Factored out an x, so we got x. And we factored out all of these, x minus 2 cubed. So then we could write it like this, 2x times x minus 2 cubed times, we got x plus 2x.
So
is
we can't
3x.
just leave it
You can leave it like that, that's fine.
at the very first one?
Yeah.
Oh, perfect.
But AP test, or AP answers, multiple choice, most likely like this. And I'm almost certain the book's answers are gonna be like this. Anytime they get an opportunity to factor something out, they most often do that. 31, let's look at 31 together.
We should do all of them together, huh?
No.
together with tiny.
Oh my god, this one looks
That's
hard.
his face.
They all look hard.
I've already done all the homework for this section. It's on a YouTube video that you can't access yet.
Oh.
But you'll get a text in a few days giving you the link.
That text reminder system is the best.
It really
does.
is.
I love it.
One day I
It's
didn't write my
amazing.
homework down.
It's the nicest thing.
You came to the rescue.
Alright, so we've got this outside function. What's the outside function?
U to
U
the
To the third, something to the third.
Oh,
And what's inside?
One
One
minus
motion
one over
is
one.
Right. So when it comes time to take the derivative of the inside, what do we have to use?
Quotient rule.
Okay.
Ugh.
Alright. So what we're gonna have here is, let's say, we're gonna go back to the notation that I used here. Like this guy right here. When we take the derivative of a composition of function, it's the derivative of the outside function with respect to the inside function, treating the inside function like it's just its own little variable, not changing it, and then times the derivative of the inside function.
Would the numerator be the inside function?
Would the numerator be that quotient is the inside function.
The whole thing.
The whole thing is the inside function.
Alright.
Okay, so here's how it's gonna go. We're gonna take the derivative of f. Okay, I'm gonna write this out like I started to. I think this works nicely. So, what we're gonna do
Variable.
is, well, v is a function, right? It's g of x. Right, we know that g of x is 1 minus 2v over 1 plus v.
Yeah.
Okay, so we're gonna take the derivative of f with respect to g. That's not gonna be hard, that's just gonna be the derivative of something cubed. Okay. Then we're gonna go and we're gonna take the derivative of the inside function, okay, the derivative of g prime. Well, to take the derivative of the inside function, what are we gonna need to use?
Quotient.
Quotient. So that part, we're gonna need to spell quotient with a q.
That was a really good G though.
It's a second.
So that's not good. Okay, so here we are. We're at this first part. We're at the derivative of the outside function, the derivative of something cubed. What's the derivative? How do you take the derivative of something cubed?
Power rule.
Don't change rule. Oh.
Well, just the power
You
rule.
don't.
You do. You do. How do you take the derivative of something cubed?
Just quit.
Three
Right, this is f prime.
times the variable.
3 times the variable, right? The variable right now is this function.
2 second.
To the second. Okay, so that is done. Derivative of the outside.
Oh.
Times the derivative of the inside needs the quotient rule.
Mm.
Okay, but we know the quotient rule. What's the little rhyme?
OD
ID low over square plus below.
Wow, this is like a 3rd grade classroom. That was awesome.
That was
Tell us
disgusting.
what it is.
That was disgusting.
Okay, so low, d high. What's the derivative of the numerator? Derivative of that numerator? -2 minus high, which is 1 minus 2b. D low, which is what? 1. Just 1. The derivative of 1 plus b is 1 over 1 plus b squared.
Hold on.
And we can leave it like that? Like
Yep.
that's.
No, multiply that
We'll
baby out.
clean it up.
To factor
It's
those
easy to
in.
clean up.
No,
That's
multiply
all
So
that.
we did the quotient rule, which means that g prime is done. We broke it down. We've gone through our little map here. It's all finished up. So let's clean it a little. 3 times 1 minus 2b over 1 plus b squared times, this is just -2 distributed in there, -2 minus 2b. This is a 1, that doesn't matter, right? So -1 plus 2b over 1 plus b squared. 3 times 1 minus 2b over 1 plus b squared. -2 minus 1 is -3. -2v plus 2v is nothing. 1 plus v squared.
Is it alright if we work that out every time? Like simplify it and not just leave it as like.
Why would you
plus
want to do
b?
that? That's way too much work.
Yeah, simplify it as much as you want.
Alright.
Whatever your answer is, if it's equivalent to my answer, it's right.
Alright.
If you do make a mistake,
Then it's wrong.
Dang,
somewhat
I'm gonna
wrong.
fail that test so hard.
Right? If your mistake is in the simplification, well, certainly you should practice that. But you did the hard part, you did the calculus.
I'm enjoying it.
So that's the important part.
And I will love every second of it.
Isn't it weird to think that we've come so far?
No.
Like, we were in algebra or geometry, and we're in calculus.
One more together, a trig function. Y equals cosine. 46 cosine of 1 minus 2x squared. Right? So it's saying like that is inside the cosine function. There's that parentheses assumed.
Oh, no.
Take it away.
So,
So we're going to take y prime, which is a composition, so we have to view it as a composition. So it's going to be f prime of g of x. Okay? And f is what? What's the outside function? Cosine. And what's the inside function?
1 minus 2x something.
1 minus 2x squared?
Yeah.
Okay.
It is factual.
All right. So we're going to need to take, let's see.
So it's negative
it's
sign.
it's negative sign.
Make sure, because now that notation is bothering me.
Yeah,
Yeah. Yeah.
Or to be cosine
it's
squared.
good.
Negative sign.
You're so true, Alex.
Okay. So I guess here's the thing. Just so it's a little clearer, I'm going to take the derivative of that and use f prime in that
It's not the
notation.
original. It's this weird cartoon.
Okay. So I guess all I should be saying here is instead of using that little prime mark.
We've been doing it wrong the whole time?
No, not wrong. Just this notation is a little bit weird. So let me just change one little thing, make one little erase mark. Okay, if I want y prime, I just want to take the derivative of the composition of f of g of x. And that's going to be f prime of g of x, right? Where we take the derivative of the outside times the derivative of the inside.
Use the chain rule in the chain rule.
We're going to have to use it now to take the derivative of the inside.
It's chain
Hey,
section.
okay. The exasperated skies, we're done with them because it's
No.
gotta happen. We gotta do it. Okay, so keep it to yourself.
Is the chain rule in the chain rule?
So we take the derivative of the outside,
It's chainception.
and then we take the derivative of the inside, which is another composition of functions. Function and a function and a function.
Oh gosh. Oh, that hurts.
So we can just use it once to get f prime of g of x, right?
Yep.
Yeah.
Just do like
Not
negative
in
sign,
limbo yet,
whatever's
but we're
inside.
three.
Yeah. But here we're gonna have to use the chain rule
Of the chain.
again.
It's terrifying.
Oh my gosh.
Is that a yawn? It's terrifying.
Yeah, the outside.
Just for you.
So we're gonna have to start the timer or what? It's like keep you after class in a calculus class. That's gonna be silly. Okay, so first we take the derivative of the outsidest function. This is the function that's the most outside. The negative sign of that thing, of 1 minus 2x squared. Okay. Then we come over here, we're going to multiply by the derivative of the inside function, which we've made note over here we need to use the chain rule to do. Okay? So now inside of this function is outside, and this function is inside. So now we're going to take the derivative of this. What's the derivative of the outside function?
2 times 1 minus
Times 1 minus 2x.
Fine.
Okay, then times the derivative of that, of the function inside of that one,
minus 2.
just negative 2, and we're done. Right?
We're done. Do not touch it.
We've gone all the way in.
Simplify.
No.
We got, let's see, a negative 2
Oh, I see.
times a 2 times a negative sign. So
What's
4 sine of 1 minus 2x squared times 1 minus 2x.
Is it negative 4?
x times another negative.
Ah.
So it's an 8.
So your answer is no.
That's, you know, fine, that's fine.
Isn't that 1 minus 2x cubed?
Should do that.
Cubed?
Couldn't you?
Like, did I write it down wrong from the book?
No, no, no. Just if
Couldn't
you
you
multiply
combine
them
both
together,
last two?
it's 1
Oh,
minus
no, absolutely, you cannot do that.
What?
This
Absolutely
is the
not.
sign of that thing.
Times
Times that other.
Times this other thing.
Absolutely not,
On the
Kendra.
outside.
Right? Is the sign of x,
You thought it
That's
through.
like shoes.
is x times the sign of x,
When you said
hey,
it, I was like, that's
is
smart.
x times the sign of x sine of x squared?
No.
What if you say no, because it's not. Right?
So can we move that
Is
thing
the
like
sine
out
of
to
pi
one?
over 2 times pi over 6?
the sign of
No.
The sine of pi over
Definitely
12?
some-
Add that to your kitten weeping.
Weeping kitty.
Should make a list.
That's a lot.
Weeping kitty.
This is a weird kitty.
Maybe
Right?
I enjoy
There's
kitten
no
weaving.
reason.
Mr. Stewart,
So,
Yes.
I'd just
can you
like to
move-
throw in that there are many times I've got myself almost making kittens weep, and because of that, it did not.
Came as a
That's
mess.
it's very helpful.
Yeah.
Can we move the part that I thought we could left to right
In
to
the
the
front?
front?
Sure.
And then distribute the 4 into that?
Yeah.
4 minus 8x.
Alright.
But then we still need parentheses around that thing.
Yeah,
Times the sign. Okay.
got that. Okay.
Okay. Let's see.
Homework.
Take the homework off
Quiet.
now.
Quiet.
Savages.
It's a perfect.
But I do one of your own.
Okay.
55.
55?
No candy.
55. See how it goes. That's not.
Oh, we use T.
T is the stupid.
I'm using variable.
Could be a pumpkin. No, that's not.
No, that's not T. That's mine. That's mine.
C squared minus 1.
You know what? Solve it all.
Oh, God.
Alright, here we go. So I'm just going to rewrite this first as 3 times the secant of pi t minus 1. The whole thing is squared. You don't have to write it that way, but if you don't see it that way,
Dang.
then it's going to be a problem. Okay?
Oh.
So this is inside of the square.
Mm.
Okay? We could not do that.
Oh, that's ugly.
Alright. So, to take the derivative now, first we got the constant multiple rule says we can just bring down our constant multiple of 3. And then we don't have to worry about it after that. We just need to find the derivative of this. Okay, so that's great. Alright. So, the first thing we're going to do is take the derivative of the outside function. What's the outside function? Something squared, okay?
2.
So, how do you take the derivative of something squared?
2.
2 times the thing, 2 times this thing, okay? So minus 1. Okay, to the first, right? To the first. We don't need to write that. Okay, so that's the derivative of the outside. What's inside of the square function? The secant function, okay? So next to the secant, how do I take the derivative of the secant function? Secant of that thing times the tangent of that thing.
Oh.
Wait, sorry.
Times that
Oh.
Why?
Why? Why this? Is that what you're asking? Why is that?
And why is it a thing? Oh, because we're treating it like a variable. Okay.
Right, the inside is just, right, it's an inside function. So now, after that, we have to multiply by the derivative of the inside of the secant. Okay, the derivative of pi t minus 1? Pi. It's just pi. And that's it, right? Now we're fully, so there's nothing inside of that.
Why is math so easy when you?
Where did the secant, 2 secant, and then there's another secant,
Say what?
Say what?
Okay, that was a mistake that you had.
Yeah.
Okay, the outside function is
Yeah.
something squared.
Yeah.
Okay, so the first First objective is to take the derivative of something squared. Okay? That something is secant of pi t minus 1. So, if you look at my hands here, the secant of pi t minus 1, right? All in these parentheses, squared.
Yeah.
So we did the
So we bring down the 2
Yeah.
and multiply that by that whole thing to the first power.
Just teach her their hand.
Okay? So
Yeah,
we're
just
done.
teach us all with your
And then
hands.
we come over here, we're done doing the power rule, and now we're going to take the derivative of the inside of the square function. The inside was secant of pi t minus 1, so then we take the derivative of secant of pi t minus 1, which is secant times tangent. And then we go inside the secant, we take the derivative of pi t minus 1, which is pi.
Yeah. I'm just trying to figure out how we got there's 2 secants.
I just explained it.
I'm so lost about that.
This comes from
And that comes from the power.
the power rule,
Yeah.
right? We took the derivative of the secant of pi t minus 1 squared,
Yeah.
right? So this came down here, and then we subtracted 1 from that.
Yeah.
Okay, inside of that square function was the secant of pi t minus 1 was the derivative of the secant of pi t minus 1.
Secant times.
Secant times tangent.
What's your 2 secants now?
Because you have the first one.
This one is from doing the power rule. This one is from taking the derivative of secant.
Alright.
There's
It's
5
5
minutes.
There's 5 minutes.
Homework.
There's 5 minutes.
Two.
Problem is my least favorite problem.
It's amazing how much money you can do that.
Right?
So this secant is from taking the derivative of a power function, bringing down the 2, multiply by the thing, raise it to the first power. That's that. And then we multiply by the derivative of the inside. The inside is secant. Derivative of secant is secant tangent. Then we take the derivative of the inside of that function, which is just pi.
So that is the derivative of f of g of x times the derivative.
Times the derivative of g.
It's basically the chain form.
The what?
The chain.
It's the chain rule, yeah.
Okay.
We did the chain rule, and we did the chain rule again.
Okay. That's where I was confused.
We did the chain rule twice.
Looking at it.
Once you get on a roll though, once you start seeing, oh, there's a function inside a function, that's inside another function, it kind of flows nicely. You just start like taking the derivative of this function, then you look inside that one, you unpack the derivative of that one, you look inside that, you unpack the derivative of that one.
It's like those little cup things.
Yeah, it's like the
The
choice
triangle.
bells.
Oh.
Okay. Now in the last couple of minutes, if I just turned you to your own devices, you probably wouldn't do anything but talk. So what I ask you this: what's the derivative of x squared? What is d dx of x squared? 2x. What's d dx of now that we have this ability? What's the derivative?
3 times
2x plus 3 times 7.
Times 2.
Oh.
So 6 times 2x plus 3 squared. What is d dx of y to the third? Okay. Just take note of this. You see how we're taking the derivative, what we call with respect to x. X is the independent variable. X is the thing that we like, we move over 1 and then we're looking at a change in y, right? We move over 1 on x, how much did y change? That's kind of, we're looking for the slope, right? Looking for the change in y versus the change in x. Well, all of these work if we're taking the derivative with respect to x. With respect to x. With respect to x, this isn't an x. It's a y.
Yeah, so
What is
so
y?
y cubed?
This is y cubed.
Isn't y basically f of x?
Yes.
Why is that?
Y is a function of x.
So that would be like It's a function of a function.
It's a function in a function again.
So
That's exactly what this is.
So the outside function would be u
U to the
of
third.
v, and then the inside would be
Y, right? So by the chain rule, we would just take 3 times whatever that function is squared times
E derivative of y.
derivative of y.
And you write it like that.
You can write it like that. What we're going to do,
Would the derivative of y just be 1? Or
no, if with respect to y it would be, but with respect to x, we don't even know what it is.
Oh.
Okay? We just write, well, we're going to write dy dx. Right? Same thing, different notation. But this notation helps us out. Okay?
It's like we finally get a grasp on something,
And then it's like,
and then
oh,
right at the
yeah.
end of class, you completely blow our minds.
It's like,
again.
yeah.
No, it's just the chain rule, right? It's just the chain rule. Just a different way to write the chain rule. When we're taking the derivative with respect to something that isn't the variable we're talking about, we
Yeah.
have to then use the chain rule.
You love this. Oh, this is so easy.
Gets to the next part.